So this is the GATE 2023 question number 24. So this question is, as you can see, that it is the logic circuit question. Which one of the following options is correct for the given logic circuit? So this is the logic circuit which is given, and you can see that P and Q are directly connected to an AND gate, and P is actually bifurcated into two parts as an input to this AND with a NOT, so it's a NAND gate. After that, this NAND gate output is connected to the output which is coming from this AND gate and is input to an OR gate, and that is the X, that is our actual output. So what we need to do is that we have to put P and Q here and check that whatever X we are getting is given here or not. So these are the things which we will see for each and every options. We will try to look that which option is correct. So let's see the step-by-step solution. Okay. So here what I have done is that the same circuit I have drawn, this is that AND gate, this is NAND gate, and this is the OR gate. Now this is the P and Q which is given in the question. What I have done is that I have introduced some other variables at different junctions. So this I have introduced to be at A, this is B as the two inputs to this NAND gate. I have introduced this as the point D, which is the output of P and Q when it is passed through an AND gate here, and C is the output of this NAND gate which we are getting, and C and D as the input of this OR gate, and finally we get X as the output. Therefore, if P and Q are directly connected to an AND gate, therefore D should be equal to P into Q, P dot Q actually. So P dot Q should be equal to D. P is connected to a NAND gate as A and B inputs, which I have introduced here. Therefore, A should be P, because P from P only the signal is going towards A as well as B. So A is equal to B is equal to P. This is also we have seen it here. Now what will be the C? C will be according to the NAND gate. It is AB bar. Okay, so this is NAND gate, and that's why we are writing A dot B and whole bar. Bar is corresponding to the NOT, this NOT here. So this is A dot B bar. And what about X? X is C plus D, because this is an OR gate. So this is OR gate. This is AND gate. So we will see these 3-4 equations, that is D is equal to P dot Q, A is equal to B is equal to P, C is equal to A dot B bar, and X is equal to C plus D. These are the 4 things we will check each and every time. So first option was given as P is equal to 1, Q is equal to 1, and we have to check whether X is equal to 0 or not. So we start with P is equal to 1, Q is equal to 1. Therefore, A should be equal to B is equal to P, that is equal to 1. Therefore, C is equal to AB bar, that is 1.1 bar, that is equal to 1 bar, which is 0. Correct? Now D is also equal to, what is that? D is this. So it is P dot Q. So P dot Q we have done, and we get, as P and Q both are 1, so becomes 1.1, that is equal to 1. Now X is equal to C plus D, because it is passing through an OR gate, C and D. So X is equal to 0, which we have got C as 0 and D as 1. So 0 plus 1 will be 1. But what X is given here is 0. Therefore, this X is equal to 1, or this particular circuit is not valid. Where P is equal to 1 and Q is equal to 1, X cannot be 0. Therefore, this is not the correct option. The second option given is P is equal to 1, Q is equal to 0, and we have to check whether X is equal to 1 or not. So P is equal to 1. So we have got P is equal to 1. Therefore, A should be also equal to 1, B should be also equal to 1, because P is directly connected to both A and B inputs, which I have introduced. Therefore, A should be 1, B is equal to 1. And C is, since C is the output of the NAND gate, it is A dot B bar. Therefore, A is also 1, B is also 1, so 1.1 bar. So 1 bar, that is equal to 0. C we have got. What is D? D is nothing but the AND gate, where the inputs are P and Q. Therefore, P dot Q. P is 1, Q is 0, therefore 1.0, which is 0. So D and C we have got. X is nothing but the output of the OR gate, that is C plus D. Therefore, it is 0 plus 0, that is equal to 0. But X is given as 1, so this is incorrect. Third option is P is equal to 0, Q is equal to 1, and X is equal to 0. Now, since P is equal to 0, therefore A should be also 0, B should be also 0, because again the P is directly connected to A and B, which I have introduced. Therefore C should be equal to A dot B bar according to the NAND gate which is there. So that will be equal to 0.0 because A and B both are 0. So 0.0 bar, so it becomes 0 bar, that is equal to 1. Correct. Now D is equal to P into Q because it is an AND gate, P dot Q. So that becomes P is 0, Q is 1. So 0.1 becomes 0. And X therefore is equal to C plus D because it is an OR gate. Therefore it is 1 plus 0. So let me write it completely. 1 plus 0, that is equal to 1. But X is given as 0. Therefore it is incorrect. D option, P is equal to 0, Q is equal to 0 and X is equal to 1 is given. We have to check whether X is equal to 1 for these two inputs or not. So P is equal to 0. Since P is equal to 0, A is also 0, B is also 0 as we have seen. So C is equal to A dot B bar because it's a NAND gate, and since A and B both are 0, so 0.0 whole bar, 0.0 is 0 again bar, that is equal to 1. We have got C is equal to 1. But what about D? D is the output of the AND gate P dot Q. So P dot Q becomes again 0.0 because P and Q both are 0, that becomes 0. Now X is the output of the OR gate where the inputs C and D. So C plus D, if you do, this becomes 1 plus 0, that is equal to 1. And X is here 1. So it is matching with whatever option. This option is only the correct option because X is equal to 1 is matching with what is given in the options. Therefore, correct option is D. So let's come to this. So P is equal to 0, Q is equal to 0 and X is equal to 1. This is the correct option. Thank you.